So dear participants, faculty members from different colleges, research scholars and students, welcome you back to the 7th day of 7 days international FDP program to be held virtually on interdisciplinary application of science and artificial intelligence for sustainable development, organized by the Department of Biochemistry, IQAC and IIC cell of RVS College of Arts and Science. Today on the 7th day, we have Dr. S.P. Suriyaraj, Associate Vice President, AIC RISE, Rathinam Technical Campus, Coimbatore with us. He will be addressing on the topic From Innovation to Impact, Building Sustainable Enterprises Through Intelligent Technologies. So we are happy to welcome Dr. S.P. Suriyaraj, our prestigious alumni of 2006 batch of biochemistry for this session. We welcome you, sir.
Thank you.
Yeah. Now I hand over the session to Dr. Parvata Vardhini. Ma'am, kindly give a brief introduction about Suriyaraj, sir, and then you can proceed to Suriyaraj session. Thank you.
No, ma'am. Thank you. Respected Head of the Department, distinguished resource person, esteemed faculty members, and dear participants, a very good afternoon to all. It's my great pleasure and privilege to introduce our esteemed resource person for today's session. We are truly honored to have Dr. S.P. Suriyaraj sir with us as the resource person for today. Dr. S.P. Suriyaraj holds a Master of Science in Nanoscience and Technology from Bhatia University and PhD in Nanobiotechnology from PSG Institute of Advanced Studies, Coimbatore. He was a postdoctoral fellow at Department of Biotechnology, Indian Institute of Technology, Madras. His research interest lies in the area of bioremediation, water treatment, and drug delivery applications. He has more than 8 years of experience in research, innovation, and incubation in the field of nanobiotechnology. He is passionate towards developing technology startups and budding entrepreneurs. He has produced more than 15 scientific publications, including original research papers, review articles, and book chapters, and mentioned many bio-nano startups and innovators. He has an industrial experience of more than 3 years as a CEO and senior scientist in Adult Biomed India Private Limited, Coimbatore. Currently, he is an associate president, strategic grants and proposals, AIC RISE, supported by Atal Innovation Mission, NIT Aayog, Government of India. We are confident that today's session will be highly informative, engaging, and to all of us. We look forward to gaining valuable insights from his expertise and experience. On behalf of our department, I extend a warm welcome to Dr. S.P. Suriyaraj and express our gratitude for accepting our invitation and sharing his knowledge with us. With these few words, I welcome Dr. S.P. Suriyaraj to take over the session. Thank you.
Thank you, ma'am. So please share my presentation.
Yeah, we'll be sharing your presentation, Surya.
So before going into the presentation, let me thank the RVS College management, head of the department, faculty members, participants for arranging this wonderful session. So proud to be RVS alumni in presenting this topic on innovation to impact, and also thanks to everyone for arranging this. So the presentation is not about just showcasing the technology or something like that, or I'm projecting my research, what I have did. It's not related to that. But the topic today is to motivate the faculty, staff, students towards the entrepreneurship and product development oriented. So after I completed my BSc in biochemistry from RVS College. So into more on product developments and incubation center based applications. So the today topic, even though I'm going to share my own research experience, it's considered as my research journey and how I converted my ideas into a prototype and that prototype into a real time products and how I made it to into the startup supports. Next slide please. Yeah, next. So the idea behind in I want to say during my bachelor's degree itself, I got very interested in nanotechnology. I can say in 2006, the nanotechnology was booming that time. All the academics, industries have been talking about this nanotechnology. But nobody, most of the people, not aware. Other than this, 10 to the power 9 or something like that. Other than that, there is no idea about what it really means because we not have any good facility or a good academic institute to teach this nanotechnology at that time. But government has supported various workshops and conferences to understand what is nanotechnology. So we some faculties supported from RVs like Samina ma'am. I think Sivalango sir also joined. So I thank these faculties to encourage me during that time to explore what is real nanotechnology. So used to participate various conferences related to this nanotechnology during the UG itself. So after that, I just shift to nanotechnology for my MSc in Bharata University, where it's totally like a physical science. I thought it's maybe basically in molecularity or whatever maybe. At least it may interdisciplinary, but actually my master's fully on physical science, where I started studying quantum mechanics, solid state physics, nanoelectronics in the first semester itself. It's total real challenging for me to understand the atoms and electronics, but that is what the real nanotechnology. To understand nanotechnology, we need to have that idea or basics. So really tough for me, and also of course that gives the experience for me to think on interdisciplinary and connecting this nano with life science. So during my master's, so I just left to DST ARCA, Advanced Research Center for Powder Metrology. I got an internship over there for my master's itself. So where it's really sparks, rather completing as a normal internship for my master's. This ARCA, it is a DST center. Can go back previous slide. Yeah. So in ARCA itself, they worked on various water filtration applications, and they have incorporated with various nanometals, especially in silver nanoparticles. So now everybody was working on that, but think of about 15 years before. So rather developing silver nanoparticles in laboratory scale, this ARCA center almost producing this material more than 10 liters, 15 liters in the large scale. So I exposed to that factory to synthesize large level quantity of nanometal synthesis. That is not the limit where, and also I implemented this nanometal system into the water filter, and we started developing into a real-time product. So that sparks me how we can able to think on large scale possibilities and how we can convert the lab scale into a large scale system and how we can real time applications into the for the society. So that gives the sparks. Almost I completed my internship. It's not, I can say it's a research internship. I just want to supposed to enter into some factory where keep on synthesizing the nanomaterials. That is the only job for me to do over there, but still it gives the experience for me to think on what the real commercialization is means. So next slide. So from that working on this nanotechnology boosted me to continue my PhD. So in that time from Coimbatore, PhD Tech IAS, they offered nanobiotechnology program. I was so wondering, even the nanotechnology, the nanobiotechnology is the one of the course they have offered. So I'm so happy to take my PhD in nanobiotechnology and start working with various materials. But again, I just want to explore that ARCA experience here in PSG to come up with a product oriented, not with any lab scale or at least even in the translation research. So I was supposed to work with various nanomaterials, almost more than 10 nanomaterials I have developed for the water treatment application. But we went to real field, collect samples, bringing into the lab and testing the facility rather creating a spike water or something like that. So that experience gave me like how the material works in the real time system of polluted water. So for example, we are working on like water treatment, and groundwater means we are simply diluting the ions in distilled water, doing some studies never works. So we used to go to contaminated sites. Say for example, we worked with fluoride and nitrate contaminated groundwater. So I used to travel Pennagaram and that Dharmaburi district. So I collected groundwater samples where it high level of fluoride nitrate, bringing to the laboratory and expose these nanomaterials into this groundwater. So that gives the real experience for me to how it really works in the real time system. And based on that also, like we cannot put this powder or something like this in a real time filter, so we need some substrate for that. So I chose various solid substrate to incorporate these nanomaterials into the water filtration. So I choose like activated carbon, ceramic membranes, and nanofiber membrane. So but these nanofiber membranes are really like gives a good results into the groundwater treatment. So how we can do this nanofiber membranes? Is it feasible or it will be viable? So like we developed the own electrospinning facility in the laboratory itself, and we started creating many nanofibers, and we incorporated these nanoparticles in the fibrate membranes, and we started doing some research, and this was published in Royal Society of Chemistry that time in 2012. We can say 13. So we have completed this work. And so it's really interesting that they have the facility to characterize these nanomaterials, how it really behaves towards the organisms. So since I chose microbial route of synthesis compared to physical or chemical methods. The next slide. Okay. So since we are from Coimbatore, like Pollachi is nearby, Kanathakadu and Pollachi, they like that time now they started making the value from the coir dust waste. But before like 15 years, this coir dust from the coconut processing, they simply dump it as a mountain, something like that in the industry. It is like a pollutant hazard that time. So the people are unable to discard that. So we bring down that, we take that coir with dust to the laboratory, and we started developing a biochar from that and incorporating our potential nanomaterials which has high capacity in water treatment. We started creating some beads based adsorption models. So it's like a tablet based system where we put it into the container, and it has the capacity to absorb and control the microbial environment in the overhead tanks. Say for example, we in our overhead tanks 500 liters or 1000 liters, it's prone to fungal contaminations or algae contaminations within, like if we not treated properly beyond 2-3 months. So if you put it 1 or 2 capsules into the tank, so it has the potential to have the water clean and hygienic. So this type of product oriented things that we have explored almost 10 years before. The next. So this is like some prototype that we've developed, but the thing is that this nanofiber membrane and this carbon technology is really helpful for us to got DRDO LSRB to work on to the defense portable water filtration system for the defense people, where wherever the military persons go, they like lack of any good water resource. Wherever he can get water resource from ponds or whatever it may be, they can, he or she can put it in the this particular water can, so it automatically get filter, and the soldier can get a good water. So in this concept we have proposed, and we got the DRDL. I worked on this project as a chair of, and we successfully developed the prototype too. Next. So we, like, since I already mentioned, I use some organisms for the nanometal synthesis. Simple plain ecological or normal viable organisms will not have that much potential in nanometal systems, developing systems. So the organisms are highly like have resistance towards various metal ions, and it have the resistance towards pH, temperature, and everything. So other than like synthesis of nanomaterial, why can't we use these same organisms for any direct water filtration, something like that? I think, and we make a consortium of organisms, and we subjected these organisms into the heavy metal absorption process. So this really works. It's, we can say it has gives a 40% efficiency in treating 1000 ppm of nickel, chromium, zinc effluent that we have collected from the real-time electroplating industries located in the Nilambur. So, and also with the lab scale result, industry was really interested at that time, and they accepted our technology to install in the industry with their own fund. They spent almost more than 5 lakhs to install this all the bioreactors in the industry, and we trialed. Say for example, whenever if we think organisms really works in the water filtration, we can do it in a small scale in the laboratory by using 50 grams or 100 grams is the maximum. But think on industry. If industry is coming forward to work, take up this technology, they cannot work in 10 liters or 20 liters. They simply directly go for the 1000 liters. They put it installed all 1000-liter capacity in the industry. Now again that and they have asked, bring your organisms. Whether we need to think whether for 1000 liter how much biomass load that we need to bring up. Whether if we stick it on to like laboratory mindset of developing organisms from shaking incubator and isolating the organisms or separating the organisms, so centrifuge model, whether that really works in getting a huge biomass of 10 kg 15 kg per day, is it possible, is it not possible, right? So we come up with some intellectual process of harvesting organisms through another reactor through gravity setup. We used to collect more than 5 to 10 kg of biomass, and then we bringing that alive biomass and put it into this particular reactor, and we tried the real-time system. It was really appreciated at that time. Then within the actually this performed after completing my PhD in 2015, I can say. So I was working with this, collaborated with the industry, and we are doing this trial. At the same time, I got the opportunity to, I got postdoc position from IIT Madras. So we just developed all this technology, put the manpower in the industry. So they started this continuous batch mode, and then I left to IIT Madras. So next slide. So that time, like even though whenever if you are using the organisms, we need to have a backup of how we are removing these organisms from the again the same facility. So we are introducing some organisms and we are treating that. Treatment gets good results, and how we are reusing that organism, how we are separating that organism is really challenging. Maybe possible in lab scale, but how it really possible in industry scale. So we come up with a new technology of utilizing the biomass waste, sugarcane bagasse, coir bagasse, everything that we have made a new cellulose material. We stitches and we make a proper pre and post filters made out of this, and it has a wide effect in controlling and filtering the organisms from the reactor. So it was really appreciated. The Prasad Raju, you can see in that photo. So his advisor visited facility, and they appreciated us. So the point that I want to convey is that whenever if you are on applications or stuff, so surely will look into your technology, they will appreciate you, and also chance of getting funds for this translation projects. Okay, so after 3 years of my postdoc in IIT, so worked with various bioremediation, these waste methods to develop cellulose, especially various cotton waste and other stuffs. So with this, like I came back to Coimbatore and I worked in technology. I think
Yes. One
slides.
slides are not visible. Yeah. I think your mobile. No, ma'am. Just shows that it's a blank. Now it is seen, ma'am. I think it's okay. Can you see?
Yeah,
Yeah,
fine.
yeah, you can see the
Yeah,
slide right now. Yeah, yeah, yeah. You can continue, Surya.
yeah. Next slide. Okay, so after joined in PhD Tech, there I utilizing the matured coconut wastewater, and we developed with various cellulose based materials. Like that materials have been like high efficiency in wound healing applications. So we tried with cellulose based patches incorporated with this coconut extracts. So it has a wide applications in controlling diabetic wounds, burn wounds. So with this particular product itself, like we approached government, we got BIRAC big grants of 50 lakhs and seed grants. So with this, like we can say that within 2 to 3 years, we have successfully commercialized that product. The problem is that we can simply do the R&D in a month or in even few months, and also the repeatability also we can easily optimize. The problem what we have faced is that the regulatory issues. After developing the products, so getting into the regulatory is a very challenging for the industry. So as a academics or even as a faculty, we have to think in such a way how we can enter into the regulatory system to get the knowledge on that and to support the industry for the preclinical studies. And parallelly we have to study some physicochemical parameters, physiological parameters, strength and other stuffs, morphological analysis too. So with this data, like we apply to CDSCO and we got the license for the manufacturing, and now the product in the market in this. So this is like the way the process we need to understand it. And that's what that followed by, like we just want to again after commercializing this product, before like 2 years I joined in Atal Incubation Center supported by Niti Aayog, located at Ratnam Technical Campus, and started supporting various startups. So this was my journey, like I just want to share it to you today. So almost more than 18 to 20 startups I'm supporting so far in healthcare, agri, food tech and nutraceuticals. So if you have any any support on product development, incubation, fundings, so anytime you can approach us, we can support you. Thank you. Samina ma'am,
Ah, yes, Surya. Yeah, 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 yeah.
any questions?
Yeah, yeah. Audience, you can just open your mic and you can directly ask Surya the questions, or else you can text it in the chat box. Audience, you can just either post your questions in the chat box, or you can open your mic and you can ask questions. Is there any questions on the chat box?
And parallel, I've shared my number. So in the chat box itself, if any
Mm,
participants want to connect with me,
and
anytime
all
you
the
can call me.
designations are there. Yeah. So he'll be sharing his email ID. If anything else, you can post your queries to sir at any time. As he said that he's supporting with us with a lot of product developments, and he'll be a good advisor for applying various schemes, mainly under BIRAC and big grant projects, etc. He's a mentor too there, right? Am I right, Surya?
Yes, ma'am.
Yeah, yes, you can just invite him as even as a personalized mentor to for all these applications towards the funded projects. And audience, if you have any queries, you can open up your mic and you can directly interact with the resource person over here. So, so as this is going to be the final day of the 7 long days of FDP, the session was really very fruitful, Surya. Thank you so much. Your journey has really inspired us. You started the way you narrated is where you found the word nanotechnology, the innovative word at that time in 2006 around, and now your landing position is very huge, and your traveling was really transforming, and the transformation we saw in a real fledged way, and God bless you with a lot of more blessings, and you should be still more in the upper positions, trending, and international wise also. You globally you should be known for all your innovative things that you are being lined up with. So best wishes, Surya, for your journey to carry on with. Thank you so much.
Thank
And now, yeah. And audience, like we'll have a photo session now, followed by the final 7 days vote of thanks and a full event explanation. So I request all the audience to open up your mic, open up your videos, so that we'll have take a group photo. Audience, kindly open up your video. Yeah, thank you, ma'am. Thank you. Yeah, thank you so much. I'm getting all the faces. Thank you so much. Please open up your faces. So screenshots will be taken. Gayatri, are you taking? Thank you so much for all your cooperation. Please, we are waiting for all to see the entire faces. So very happy to see. So I hope you enjoyed the 7 days of a journey with us. Yeah. Any feedback? Thank you to all the staff members, research scholars, students for giving us the opportunity to serve you in terms of research and innovative things. So thank you so much. And madam, if there is any feedback, you can open up and talk. Anybody willing to give feedback? Yeah. Anybody willing to give feedback? Can open up your mic and you can, or you can chat in the chat box. You can just narrate in your chat box too. Yeah, that is Sureka, right? Anybody willing to give a feedback? Ma'am, I think your audio is not clear. Okay, no feedback. I hope that will be posted in the chat box. Yeah, the feedback link is also there in the chat box. So this is the final feedback link, and the session will be open for you at quite a few minutes. So because this feedback is very important, this final feedback is very important because it will take few minutes for you to completely complete this feedback link. So in the meanwhile, we'll move on to the final narrative session, and we'll end up with the vote of thanks. So welcome back. So the 7 days international FDP to be happen virtually. Interdisciplinary application of sciences and artificial intelligence for sustainable development, organized by the Department of Biochemistry, RVS College of Arts and Science, IQAC cell and IIC cell. On behalf of the entire committee, respected management, secretary, principal, vice principal, esteemed resource persons, faculty members, participants, and dear students. On behalf of this Department of Biochemistry from RVS CAS, IQAC and IIC, we are very grateful, and I feel immense pleasure and privilege to propose the vote of thanks for the successful completion of 7 days International Faculty Development Program on interdisciplinary application of science and artificial intelligence for sustainable development, conducted from 9th of February to 18th of February 2026. This as FDP was the basics of intellectual journey that connected science, research, innovations, and sustainability through interdisciplinary perspectives. So the day one, we had Mr. Faisal Mahroof, an alumni of RBS. He just projected on the. We are very grateful to thank Mr. Faisal because he navigated the way how the academic excellence could be insightful on research and in the life science projects. So, on behalf of him, we actually, as he is the alumni of RVS, he beautifully explained how scientific research can be transformed into entrepreneurial ventures, motivating participants to bridge the gap between laboratory innovation and real world applications. On day two, Dr. Shaini NK, she is also an alumni from RVS who belong to the microbiology department. We sincerely thank Dr. Shaini ma'am for her enlightening session on novel aspects on bioremediation. Her presentation emphasized advanced and emerging strategies in environmental biotechnology, highlighting sustainable solutions for pollution control through microbial applications. On day three, we had Dr. Sachin Kumar R. Patel. Our heartfelt appreciation to Dr. Sachin Kumar for his fascinating talk on the world of butterflies. He connected biodiversity, ecological balance, and environmental sustainability, reminding us of the importance of conservation biology in sustainable development. On day four, we have Dr. Deva Asirvadam. We extend our sincere thanks to Dr. Deva for his highly engaging session on AI-enabled interdisciplinary platforms for biotech and biomedical applications. He clearly demonstrated how artificial intelligence tools are revolutionizing the biological research, data analysis, and translational application across the disciplines. On day 5, we had Dr. K. Pradeep. We express our gratitude to Dr. K. Pradeep for his valuable insights into collaborative research, integrating Ayurveda and biological sciences. His lecture really highlighted us the importance of traditional knowledge system combined with modern biological research to achieve holistic healthcare innovations. On day 6, we had Mr. Lakshmanan Yan, inspiring talk on translational biochemistry from lab to industry. He emphasized industrial application of biochemical research and encouraged the participants to think beyond the academia towards commercialization and societal impact. On day 7, today we had SP Suriyaraj sir. Our special thanks to SP Suriyaraj sir for delivering a thought-provoking session on innovation-driven sustainable enterprises and how the journey of his research took place. He illustrated how intelligent technologies and innovation ecosystems can create impactful, sustainable business models aligned with global development goals. We wholeheartedly thank all the participants, faculty members, research scholars, and students from various institutions across India and abroad. Your active participation, meaningful discussion, and enthusiastic engagement made this FDP vibrant, interactive, and successful. We extend our sincere appreciation to the IPAC cell and Institution Innovation Council for their coordination, academic support, and constant encouragement throughout the program. Special thanks technical team, student volunteers, and faculty coordinators for their attiring efforts beyond the screens. A special thanks to our management. We express our deepest gratitude to the respected management of RVS College of Arts and Science for their unwavering encouragement towards academic excellence and innovation. Our sincere thanks to the secretary for her visionary leadership. Our sincere thanks to our principal sir for continuous academic guidance and vice principal sir for constant support and motivation in organizing such international academic events successfully. In conclusion, this 7-day FDP has strengthened interdisciplinary collaboration, enriched academia knowledge, and inspired all of us to integrate science and AI for sustainable development. With gratitude in our hearts and knowledge gained our minds, we conclude that this FDP on a successful note. Thank you one and all. Jai Hind.